In this video, we are going to walk through how to deal with or graph a piecewise function. So the idea of a piecewise function is you have pieces of graphs. So your graph, your function is going to be broken into three individual graphs, but you're only going to graph parts of these three individual graphs. And that's what these constraints, there's known as your constraints, and that's what's going to dictate where a graph begins and where a graph ends. Okay, so you have a linear graph that's going to be going up because of the positive slope. You have a horizontal graph at a height of 5 because it's just a 5. And then you have another linear graph that's going to be going up. So here's how I kind of take a look at this. So I start with the fact that I have constraints. I put the constraints on right away. So I know that I'm going to have one graph that is going to be from -2 to the left because my x's are going to be less than or equal to -2. So I'm going to have a -2 right here. All right. And then another graph's going to go from a -2 to a +1. So I'm going to have another section here. And then that's it, because I have another graph that's going to go from x greater than or equal to 1. So I'm going to have a specific looking graph on this side, a specific looking graph in here, and then another graph over here. And all three of them are going to be different because I got three different graphs. Okay. So I'm going to start by just trying to graph this linear equation. Now I'm going to graph probably more than I need, and I'm just going to have to erase it, okay? Because this section, this graph is going to be where my x's are less than or equal to 2, which is over here, okay? But I'm still graphing a linear equation, which starts with a y-intercept and applies a slope. So I would be starting at 4, and then I would be going up 1 over 2. However, I want that section of the graph, not this section of the graph. So I'm just going to apply my pattern back this direction, a whole bunch of points. So instead of going up and to the right, I'm going to go, because of my slope, up and to the right. I'm going to go down and to the left, down and to the left, down and to the left, down and to the left. Okay, so what I'm going to do is this graph is going to move along, move along, move along, but it cuts off at -2, at that constraint. Okay, so I'm going to get rid of the evidence on the others. Right now, the only thing that I have to worry about, so this graph, so I have a linear graph to the left of -2 is what that's telling me. And this is my linear graph. The only thing I got to worry about is how this thing ends. Does it really end in a closed circle, which is a point that's included, or does it not? All right, so the way I figure that out is either it's going to be a closed circle or an open circle, right? Like it's included or not included. That's going to be based on the fact that this is a less than or equal to. Okay, so since it's equal to, I can include that point. All right, so then now my next section, this section, this from -2 to +1 is just a 5, which means I'm graphing a horizontal line at a height of 5. So 1, 2, 3, 4, 5. Okay, so here's 5, but this graph only exists from this value to this value. Okay, so I'd be going from here to here. Okay, so now again, I want to ask the question of, should I put kind of closed in dots at the end of this, or should I have open circles or a combination of the two? That's based on your inequalities here. Neither of them are equal to, so neither of them would be included. Okay, and since it's a function, let me make this more obvious. Since this is a function, you couldn't have a closed point here and a closed point here because that wouldn't pass the vertical line test. So 100% of the time, one of them's got to be closed. Well, both of them can't be closed. They both could be open. That would be a different situation, but they definitely both can't be closed. Okay, so that takes care of that middle section. And then the last section is I'm just graphing a linear with a slope of up 1 over 1 and a y-intercept of 0. But it's going to start at 1, but I still need to draw the graph. So this graph should start here. Like if I were going to just graph it in general, I would start at the y-intercept of 0. That's what it's telling me. And then I'd be going up 1 over 1. So up 1 over 1, up 1 over 1. But this graph doesn't really start and kick in until I get to the 1. Kind of that's why I throw that constraint in right away. And then I'm up 1 over 1, up 1 over 1, up 1 over 1, on and on and on. So only this part of that graph exists. Okay, so again, I'll erase the evidence. All right, so those are my three sections for my piecewise. My first one was a linear equation that's going to cut off at -2. With a y-intercept of 4 if we had continued, and a slope of up 1 over 2. I have a middle section that's a horizontal height of 5, 2 open circles because of them not being included. And then my last is a linear equation that would start with a y-intercept of 0, but this graph doesn't kick in until we get to an x value of 1, closed circle because of the equal, and then it has our slope of up 1 over 1. All right, hope that helps.